Alright, so let's get started. If we read question 1, it says, Isaac Newton developed the laws of mechanics. Brian Newton put those laws into application when he ran a marathon in about 8.5 hours while carrying a bag of coal. Suppose Brian Newton wants to remove the bag from the finish line. He drags the bag with an applied horizontal force of 130 newtons, so that the bag has a net acceleration of 1.00 meters per second squared. If the coefficient of kinetic friction between the bag and the pavement is 0.158, what is the mass of the bag of coal? So the first thing that we want to do is we want to draw it out, okay? And we want to know what our knowns are. So all we know is that Brian had this bag of coal and he drug it with a horizontal applied force of 130 newtons. So the things that they give us in our equation are the net acceleration, which is 1.00 meters per second squared. We have our coefficient of kinetic friction, which is 0.158, and we're trying to find what our mass is. So if you looked on the front of those practice problems, there was a formula that they used, and all they did was they used Newton's second law. So we have the net force equals mass times acceleration, or the net acceleration. What we also know via substitution is that the applied force minus the kinetic force, those also equal the net force. Okay? So remember, we have our applied force, and then we have that kinetic force, the force of it actually moving. Those are going to be equal to that net force as well. So, based on that, we know that we have our net acceleration, we have our applied force, but the two things we don't have is the mass, which we're trying to find, and that kinetic friction force. So, we know that the coefficient of kinetic friction times the normal force is equal to that kinetic force. And we also know that the normal force in this situation, because we're on a horizontal surface, it's being dragged horizontally, that the normal force is going to be equal to that gravitational force. So we can safely say that the coefficient of kinetic friction is also equal to mass times gravity. So we have our Fn being substituted for mass times gravity here, or our gravitational force. So now that we have that, we're just going to plug that in and we're going to substitute it. Okay, so now we have mass times the net acceleration equals the applied force minus the coefficient of kinetic friction times mass times gravity, or that normal force. Okay, so all we did, just to refresh, is that we plugged this in for Fk into our original equation. Alright, so that's what we have here. Now we have everything that we technically need to solve for. We only have one variable, and that's our mass. So let's use a little bit of math, and let's try to figure out how we can get mass by itself. So we have mass times the net acceleration plus the coefficient of kinetic friction times mass times gravity. Okay, so we just moved this over here. Now why did we do that? Because we have two variables, we want them on the same side. So all we have to do is now factor that mass out. So we factor the mass out, we have mass times the net acceleration plus the coefficient of kinetic friction times gravity equals our applied force. So now just divide your applied force by this here to get mass by itself. And all you have to do is just plug and chug. Okay, our applied force is 130. Our net acceleration is 1.00 meters per second squared, plus our coefficient of kinetic friction from our knowns up here at the top is 0.158. We're just going to multiply that times gravity, 9.81, and we get that the mass of that bag of coal was approximately 51 kilograms. Now when you calculate this out, you'll probably get 50.4, so that's, or 50.54, so that's why we're just going to round that up to 51 kilograms. That way we keep with our significant figures and digits. So if you have any questions on this, comment below, but this is question 1 of your guys' homework for today. So we will move on to question 2 next.